Okay. Shh. Okay. Do you want to explain what the Newton balls are?
Yes. What Newton balls are is, imagine wrecking balls, kind of. Now, imagine about 5 in a row, and then pulling one back, and then letting it go. They keep on going, and the end ones go like this.
Have you guys seen that before, where it's usually like a row of silver balls, and if you hit one, the energy is distributed to the other side, and they go back and forth until it runs out, like you said. Good. So how do you think that related to when I dropped the ball, kind of rolled the ball?
Because once it hits the ground, it gains energy,
Okay.
but when it keeps on hitting the ground, it loses energy.
How? Do you know how it loses energy? Does anyone
Once
have a
it-
guess? You can try if you know.
Kind of.
Yeah, that's fine. Give it a try.
Since gravity holds us down, it's pulling down on the ball more.
Uh-huh.
So after you drop it, it'll keep on going downwards.
Okay, so gravity pulling down is sort of what somebody else said, so that's good building off of that. What else?
I feel like while the energy's flowing as the ball goes down, once it hits hits a hard surface, then it won't be able to. Then its energy will stop flowing.
Okay, so the hard surface, you think, makes, you said, the energy stop flowing? Is that what you said? Okay. Yes.
Since the ball is made out of rubber, the rubber kind of pushes itself off the ground. That keeps it bouncing
Okay, so the rubber.
until it's like it doesn't go high enough for it to make a bounce.
Okay, so she's talking about the material, and it's something that will bounce, and she said until you run out of the energy. Okay, other ideas? Yep.
Since rubber is kind of an elastic feel to it, it has a lot more energy than, let's say, hard materials like rocks.
Okay, so if I was rolling a rock around, let's say even a round rock, you're just saying the material itself? Okay,
Like foam, rubber,
okay.
something like that. That would make it bounce more since it has a bit more, it has less molecules than a solid. It's kind of like a liquid, but a solid.
Because you're saying it's like lighter.
More elastic.
And elasticity. Good. Awesome. Okay, so now just watch this, you guys. Instead of hitting the wall, I just want you to watch it. We'll see where it goes, but I'll just try to let it go. I don't know what's going to happen here. Or move back, yeah. Oh, is it going to hit the wall again? Okay. Well, let's just pretend it didn't go towards the wall, and then it just kind of rolled. Here, I bet it will do it right now. Okay, no wall. Perfect. Thank you for that. What do you think happened this time? Because before it went off of the wall. Well, this time it rolled and slowed down and stopped. What do you think caused that? What do you think?
Well, like it just didn't have enough power to
Okay, so
spin
losing.
around again.
Okay, not enough power causing it to stop. Okay, other thoughts, Evan?
Why is it curving? Like it's like the floor is flat.
What do you mean by that?
Like
now?
if you like drop the ball, it'll curve to the right.
Okay, why do you think it did it?
I don't know.
Do you think it has to do with the way, well actually I don't know, did one of you kick it? Is that what happened a little bit, a little kick?
Well, you dropped it to me.
Okay, so the same thing. Why do you guys think there's a slight curve rather than just a perfectly straight line? You've had your hand up for a while, Hannah.
Because it kind of depends on how it bounces. Like, it may be the floor is even, but maybe like there's like little, like the carpet might not be, and then so if it hits it at just like a certain weight, it'll turn.
Okay, so kind of the texture of the carpet maybe could be affecting it. Okay. What else?
I kind of think of it kind of as a car.
Okay.
It's aerodynamic, except it doesn't have an engine in it. Without an engine, it can't keep on going.
Right. And, okay, so on that note, you guys, why, though, there's no wall, and there is no engine, you're right. Why did it stop? What do you think, Taylor? Or did you, or was your answer not for that?
It was for something else.
Okay. Anyone else? Anyone have any guesses? Hannah?
Because there wasn't any energy left.
Okay, so
There might have been some, but it wasn't enough to keep it moving.
okay. So running out of energy. What else, Alexis?
I'd like to add on to hers.
Okay.
Well, the gravity is greater than the level of energy that it contains.
Okay.
So the movement slowly stops.
So the gravity's pulling it down, is what you're saying. So then, therefore, it will stop moving eventually. Good. What else?
Well, maybe because like it doesn't have anything else to transfer energy to.
Okay.
It's like with the Newton balls, they'll probably go along a
That's
little
a good
longer
point.
than a ball would. on its
Okay.
own.
What else?
Well, since the floor isn't sloped, it can keep on moving. Since sloping creates more energy, it can't keep on going. While if the ball is going upwards, that decreases energy.
Right.
So, since the floor is flat, it can go for a while, but it can't go for a long time.
Very good. And then you're saying if it had an incline downward, then it would keep going. So the energy would be increasing. Good. Okay, let's find our seats. We're going to talk a little bit about forces and motion here. Okay. All right. How many of you have done something like this where you sit on either a mat or a potato sack type of thing to go down a slide? Okay. This is what this picture is representing here. It says these kids will quickly reach the bottom of this giant slide. Once they are on flat ground, they'll continue to move forward before slowing down and stopping. Why don't they stop immediately at the bottom of this slide? So what do you think happens that as soon as the incline stops, why do they keep going for a while? What do you think, Trey?
They still have motion from going downwards because of gravity pushing them down.
Okay.
So it doesn't stop immediately because there's nothing stopping it right there.
Okay, there's nothing in the way, kind of like how the wall was there, and we saw our ball roll. So he's saying there's still energy, there's still some energy left when you get to this point. That's good. What else do you think, Brendan?
They had momentum when they were coming down.
Do you guys know what momentum is? Have you heard of that word before? Okay, so they were gaining momentum, which is energy from their downward force, and it's still carrying through for a little while. That's why they don't stop as soon as you hit the bottom, which would actually probably not be as fun, right? If you suddenly came to a sudden halt, wouldn't be quite as good of a feeling. Yes?
Well, like, if the slide was, like, made out of gravel and stuff, then the potato sack might catch on some of that stuff, but since it's on a smooth surface, then it can slide down easier.
Awesome. Do you guys know what he's talking about when he talks about like a rough surface compared to a smooth surface? Do you know what word that would be? Scientific term? Texture. We've never talked about. I think someone just said it. Oh, texture. That is a scientific word we've talked about, right? With properties. That's a good comparison. I'm looking for a different word. It's okay if you don't. We're actually going to talk about it soon here, but do you have an idea?
Train?
No?
Darn it. Close.
Okay, so here we go. And there's another term here that you guys are already describing I'm going to introduce, and it's inertia. Have you guys heard of inertia before?
No.
Okay. It says the kids continue moving because they have inertia. It's the tendency of an object to resist any change in motion. So it says you see the inertia's effects all the time. Once an object is moving, it tends to keep moving, and once it's at rest, it tends to stay at rest. Something has to get it moving. So what do you think has to get it moving? What has to move something?
Force and energy.
Yeah, beautiful. A force. You guys heard of a force before?
Yes.
Okay, very good. And a force is, well, there she got it. That something is a force. It's a push or a pull, okay? It can be like a gentle thing, like just pushing a book or pulling a book towards you, or it can be something like massive and a large force like an erupting volcano. So on that note, when you think of pool, I think of forces a lot, and I'm sure you do too. So let's say that I hit the cue onto this ball here. What was my force that made the energy get to that first ball? Yes?
The stick.
Okay, so the stick, my energy behind the stick pushing that ball. And then what force would be affecting this ball or that ball?
The ball that's going towards
Okay,
it.
so the ball perceiving it. Very good. Okay, it says, how do forces affect motion? It says, think of a large ship. In order for the ship to start moving, force from huge propellers has to overcome the ship's inertia. So a desire for the ship to be still, basically, when it is standing still. When the propellers turn, the blades push against the water and move the ship forward. How many of you have been in a paddle boat before? I almost said propeller boat. What's it like when you try to get going? Do you know, can you remember what it's like? It's probably been a while since you've done it due to the weather. Do you know what it's like?
It's kind of like hard at first, and then once you get going, it's a lot easier.
Okay, and that's because of inertia, you guys. That initial, it wants to be still. So you can kind of have this motion where you're pressing really hard on the pedals to get going, and then all of a sudden it will get easier, like you said. So, all right, here's what it says. It says, once the ship gets going, inertia makes it tend to keep going, just like he said. But eventually it has to slow down and stop. This is the force that we were talking about with what Taylor talked about, and it's another word that starts with F. Can you guys think of something where it can be either smooth or bumpy? Ella?
Friction?
Yes, awesome.
Friction.
How many of you have heard of friction before? You've heard of it. It's another force. It's resistance for motion with two objects, such as the ship's hull and water, or just like with the paddle boat, the same idea, but on a much smaller level, of course. Rub against each other, so it is the force of two objects pushing against each other. You guys think of examples of friction in everyday life? You already gave one with the slide. If it was smooth or gravelly, what would be another one?
When I smoothen my rock?
Okay, so would there be a lot of friction or not very much friction when you're doing that?
Maybe not as much because
Yeah.
it's not going that hard.
And it's smooth. Yeah, okay. What would be another example?
Like when you like put your hands
Yes. What happens when you do that?
It gets like hot.
Yes. Are we used to doing that in our state?
Yeah.
Trying to get your hands warm, use friction to do that. What else? Where else do we see it? Other people? Yes.
When you rub your socks on the carpet.
Okay. You create friction. Have you guys done that before? And then usually you go shock your brother or sister after that, right? What else?
When you're driving, the tire is having friction with the ground.
Awesome. And it can depend on the kinds of tires too, because you can have like smoother tires or tires that have more grips on them. And what else?
When I go rock climbing, I sometimes forget to wear my gloves and I get rope burn in my hands.
Okay. So you've experienced that too. So what do the gloves do for you instead? Does it help?
It's like a protector for the surface of the skin, so it's less likely to get friction.
Okay, good. What else?
How do I put this here? Alright. Sorry. So you know how survivalists like make fires by twisting a twig?
You're right. Yes.
That's how they use friction. They use friction to their advantage
You're right.
by twisting the stick to make a spark. Once the spark hits the wood, which is an igniter, it ignites it. Since it has oxygen, it keeps on going until you blow it out.
Very good example of using friction. That's a great one. What else,
Well, I
Ashley?
heard if you take like a balloon and put it against your hair and rub it, it'll start like following it or
Yes,
take it
you
away.
probably thought of that from the sock example. Yep, static electricity. Good. I put a few of my own examples. Oh, wait. Well, we already talked about this. Does a smooth surface or a rough surface make more friction? Why? So which one has more friction?
I would say.
Oh, something else? Or are you going to answer? I'm sorry.
I was gonna say,
Okay.
like my dad, I was helping him fix my mom's car once, and we had to change her brake pads,
Okay.
and that's the reason that your tires, like whenever you pull the brakes, they squeak.
Yes.
Because of the pads, like whenever you pull the brakes,
Yeah.
two pads have to like come together to
Right.
stop your wheel, and then after a while they'll get like eroded down.
Yes.
And then
Good
there's
word.
like a thing on there that'll make them squeak, so you know that you need to change.
So then you want some more friction, right? Because they're wearing away. Good. What else?
This is kind of bouncing off of what Keaton said, but like when you move your hands together with a stick against the wood, the I can't remember what it's called, but like the little tiny organisms that's in something that like holds it together.
Like
The-
molecules, or
Yeah,
what do you mean?
molecules.
Okay.
That, they'll like start to move faster because
Because they're.
yep,
the
and then
added
they'll start
heat.
to create heat.
Is that a Boy Scout analogy for you? Or
Yeah.
something you know? Okay. Okay. How about? Do you have the answer for this one, Keaton? I know we kind of hit on it, or do you want to
yeah.
bounce off of what they said?
It's a rough surface.
Right.
Since you can grip on a rough surface more, and I also have 2 more examples of matches. Since friction causes the phosphorus on a match to ignite,
Very good.
which is the powder stuck to the match.
You're right.
It kind of makes it on fire.
Well, it adds the heat because of the friction, and then that's how you light the match.
And it's
that's a good
the
example.
same thing with a lighter, except the lighter has oil in it.
Okay, so the same idea when you go like this, you're causing friction, and the oil's heated. I don't even know for sure actually.
What happens is there's a little wheel with little how do I what is it again? There are little iron bars on it.
Okay.
So once you push it downwards, it creates a spark,
Yes.
which goes towards the gas valve,
and then that's how you get your
Yep.
your flame started. Awesome. What else do you think about that, or do you have something different?
I was talking about the lighters. They
Oh,
have
okay.
flint in them.
Oh,
to start
flint.
the spark.
Okay. You guys are more knowledgeable about that than I am. I put some of my own examples. So here's one that you guys will be doing soon if our warm weather ever comes. This is showing that the direction of the motion is in the opposite direction of the force of the friction. So when you're mowing, the friction's going that way and the motion is going that way. So there's one example. Evan already gave this example of rubbing hands together, creating friction and warmth. This one looks painful, I think. I think what these kids did is they took like a wagon and took the wheels off, replaced it with skis. Does it look like it's going very well?
No.
So do they have too much friction or too little friction? Too much. So he's not having a good time, and I don't know about his sister or friend, but the dog looks happy, right? And then what's this guy's deal? Too much or too little friction?
Too much.
Yeah.
Too little.
Too little. Yeah, that's slippery. That's what happens with, and that's why skates for hockey too. It actually is creating heat when it's on the ice, and that's why you can skate and glide along so easily because there's less friction then. So, yes.
A cool thing that I learned is that when you're on the ice, since friction makes heat,
Right.
when you're kind of skittering on the ice, I have to kind of show this. You gotta
Go
go
ahead and do a demo. Okay,
This-
yeah. Like when you're
yeah,
almost
like
falling.
sliding. Yeah,
Yes.
it can actually melt the ice.
Because you're actually making it worse almost when you're trying to gain your balance.
Yep.
Because you're creating more heat and making it more slippery, yeah. But that's kind of out of our control, isn't it?
Yep.
But that's a fact. And that's partly why there'll be the marks are partly from the blade itself on the ice, but it can be from it actually melting the ice a little bit too. Yes?
Is that why, like, on matches, like when you, like, strike it, is that why it's, like, a rough surface?
Yes. Because it will create more friction, yes. Yep. Good. Okay, let's see what we have here. Okay, so that brings us to get you guys all this talk of inertia and friction and forces is from the great scientist Isaac Newton. I know that we've talked about him a little bit when we did our scientist research, but he had ideas about inertia and forces, and it's also called the law of inertia, the first law of motion, and I know that you've probably heard of the 3 laws of motion. We're just talking about the first one right now, and here it is. An object will remain at rest or continue moving at the same speed and in the same direction unless a force acts on it. So here's one little scenario. It says the problem. You and your friend want to move a dresser from your parents' room to your room. The dresser has 4 drawers and it's too heavy to move. What would you guys do? Maybe you've already been through something like this. What would be something you could try? Just looking to see if I get new volunteers at all. What would you try?
I would,
There's a couple different ways.
maybe I would put it on something smooth.
Okay.
Like
Like what?
Either a really big pan or a sled.
Okay, so you're a pan or a sled, and what does that do? Does that it makes it smooth? So is there more or less friction when you do that? So there's less friction, so you could move it that way. Have you guys seen those furniture sliders ever?
Yeah.
I have a few different sets of them. They're like a miracle because you can sit there and be pushing on your dresser so hard, and then you slide those underneath, and it suddenly just like glides along because there's less friction. There are other ways though. So what other? That's a good method. What else could you do?
When we were moving our dresser, we flipped it over on the flat part and just pushed it.
Okay, so why do you think that was easier than having like the legs?
Just flat and yeah.
Yeah, a flat, smooth surface, and rather than having 4 legs that you're trying to push, it's a whole, almost like the pan or the sled that she described. That's good. What else could you do?
Like when my mom wants me, when I want to move my dresser, mom makes me like clean out my drawers.
Okay.
So then I usually take them all out and then I move it.
Okay, that's actually my answer for this one. How many of you are thinking that? Just raise your hand. Take the drawers out. This isn't talking about moving it, into a moving van, into a new house. It's just saying from one room to another. But it's very heavy and it's got 4 drawers. How do we make it lighter? Take out the drawers. So your mom is right. Alright, so here's what it says. I have your solution as my answer, but all of these were actually good solutions. Remove the drawers, carry them one at a time, then carry the empty dresser. Problem solved. And it says, look at the science. The dresser was too heavy to move, even by 2 people, because of its large mass. Mass is the amount of matter something has. You and your friend could not provide enough force to move the mass. Can you guys see that they're related now? How mass and force are related? So the same 2 people, you and your friend can move the dresser when the mass is decreased. But at one point it was too heavy. Taylor?
Well, this is kind of something I discovered when I was like 7.